This question is asking me to find the vertical asymptotes of this function. Vertical asymptotes happen where a denominator is equal to 0. When a denominator is equal to 0, I'm either going to have a vertical asymptote or a hole. So the first thing I need to find out is what is going to make this denominator equal to 0. Well, this is a quadratic. So I have 2x squared minus 5x minus 3, and I'm going to set it equal to 0. Well, there's a couple of ways I can find out what that is. I can either factor it, or I can use the quadratic formula. I'm going to try factoring. So I'm going to use the surefire method of factoring, which if you're unfamiliar with it, I have a video on that also. And I'm going to multiply my a term times my c term, and I get negative 6. And then I'm going to look for factors of negative 6 that when I add them together give me negative 5. So I might think some form of 3 and 2, but to get negative 6, one would have to be negative, the other half would have to be positive, and when I add them together I would not get negative 5. So the other factors of negative 6 that could possibly work would be 5 and 1. I'm sorry, 6 and 5 and 1. 6 and 1, with the 6 being negative. So when I add negative 6 and 1, I get negative 5. So I'm going to rewrite my quadratic here as 2x squared minus 6x, that's this 6 right here, plus x, that's that 1 right there, 1x, minus 3 equals 0. So all I have done here is I've taken my negative 5x and I've divided it into two terms, positive x and a negative 6x. Now I'm going to group these. So from this group here, I'm going to factor out a 2x. So I have 2x times x minus 3 plus, well, just 1x, 1 times x minus 3, not 1x, equals 0. And now I see I can use the distributive property in reverse, and I can have 2x plus 1 times x minus 3 equals 0. So to make this, we're going to use a zero product property now. To make this equal to 0, x would be equal to negative 1/2. And to make this equal to 0, x would be equal to 3. So those look like my two possibilities here for vertical asymptote. Let's just take a look at the function, the original function here. 1 minus x over our quadratic. So I can go 1 minus x over, and I'm going to rewrite our quadratic now in factored form, 2x plus 1, x minus 3. And since there isn't anything that will cancel out in the numerator and the denominator, I know that I don't have any holes, but what I do have are two vertical asymptotes. One at negative 1/2 and one at 3. So I've entered it into my calculator and I'm going to graph it. Zoom 6. And indeed, it looks like I have vertical asymptotes at 1/2 and at 3. Most of the action is happening kind of concentrated there towards the middle, so I think I'd like to change my window to be like negative 4 to 4. And I'll graph it then. Looks a little bit better. Kind of hard to see what's going on in here. I'm guessing it's just kind of going from negative to positive. In fact, actually looking at my equation here, I can see that I have a 0 where x equals 1. So it's probably crossing, well, it's definitely crossing the x-axis where x equals 1. But I have my vertical asymptotes at negative 1/2 and at 3. And then the next part of the question says, you should have found at least one vertical asymptote. Let's call the equation of the asymptote furthest to the left x equals a. So I'm looking at this asymptote right here, and I'm going to call it x equals a, so x is equal to negative 1/2. And I'm supposed to find, well, what is the limit as x approaches negative 1/2 from the positive side of my function? Well, as I'm approaching negative 1/2 from the positive side, so I'm going from the right to the left, I can see that my limit goes down towards infinity, negative infinity, so that limit is equal to negative infinity. As my limit x approaches negative 1/2 from the negative side of my function, well, I'm approaching from the negative side here, and my limit approaches positive infinity. So that approaches positive infinity. I know that it's going towards either negative infinity or positive infinity without looking at the table because it's a vertical asymptote. And that's what vertical asymptotes do. When the graph approaches a vertical asymptote, it goes towards negative infinity or positive infinity. In fact, that is the definition of a vertical asymptote. When I have the limit as x approaches some constant a of a function, if that limit is either equal to positive or negative infinity, that gives me a vertical asymptote.